Penuh kesungguhan Akademi Youtuber Malaysia Langkah laksana dengan jitu Penuh bervisi guru AYU Mencapai misi yang satu Pervisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi taala wabarakatuh. Indah berbalam si awan petang berarak di celah pepohon arah. Pemanis kalam selamat datang. Awal bismillah, pembuka bicara bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Madani dan selamat datang ke kelas tuisyen online percuma bagi subjek Fizik SPM Tingkatan 4 yang dibawakan khas oleh anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-Didik Malaysia. Bermula percuma, selamanya percuma. Jadi seperti biasa, sebelum kita mulakan kelas pada malam ini, ayu kita mulakan dengan Ummul Kitab Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin ya rabbal alamin. Jadi mari kita lihat siapa yang ada bersama-sama dengan kita pada malam ini. Kita ada JTZY. Okay, hi. Thank you for being here. Terima kasih kepada yang sudi bersama dengan Cikgu Hasnitah pada malam ini. Kepada yang baru saja pertama kali mengikuti kelas ini, saya Cikgu Hasnitah dari SMK Baganjaya, Butterworth, Pulau Pinang. Dan pada malam ini, kita akan bincangkan satu lagi tajuk yang untuk tingkatan 4 iaitu 6.1 6.1 Refraction of Light. Dan kepada semua penonton, jangan lupa cikgu ada pin pada pin message di sana, pautan kepada nota PDF yang anda boleh muat turun dan cetak keluar secara percuma saja, boleh digunakan bersama-sama dengan kelas ini. Kalau tak print sekarang, jangan risau, anda boleh print out kemudian. Okay, you can follow this lesson first and then later you can print them out to be used together with this video. Kita ada Nicholas. Thank you very much Nicholas for being with me. Really appreciate. Okay, kita juga ada Mr. Madan Mohan. Again, thank you very much for your presence. Okay, cikgu ucapkan terima kasih banyak-banyak kepada semualah yang sudi bersama dengan cikgu pada malam ini. Jadi, guru-guru dan anak murid sekalian, tanpa melengahkan masa, without further ado, let us begin with our lesson tonight. It is 6.1 Refraction of Light. Okay. So this is our first topic in chapter 6. For this week, we only have one physics tuition classes for Form 4, and for next week we will again started with Form 5 Score A+ with Cikgu Rosemawati. Okay, and this is my all the teachers in physics panel in Akademi Youtuber. These teachers helped me a lot in conducting the free online tuition classes and also producing videos on physics, which you can find in this app, Akademi Youtuber apps. For those who didn't download yet, anda boleh muat turun. Siapa yang belum muat turun apps ini, boleh muat turun di Android anda sekarang. So what do we have inside this app? We have thousands of videos, PDPC videos, not only for physics, but many other subjects from preschool until pre-university level. So we hope these videos help those teachers, especially students out there, as an additional references for your subjects. All right. Okay, and today, students, if you are ready and good to go, let us begin with our first learning standard this evening, 6.1.1, to describe refraction of light. For this module, it will be in dual language. So for those who are not in DLP classes also can follow this lesson. Siapa yang bukan DLP pun boleh follow kelas ini kerana nota yang cikgu sediakan latihan adalah dalam dua bahasa. Alright. Okay, students. So actually this topic is the continuation from 5.4, refraction of wave we learned before. Okay, so I believe you know readily what is refraction of light, and this is example of phenomenon in our daily life which relate to our topic this evening, refraction of light. Okay, as for the first GIF, you can see a thermometer appear to be bent in oil and in water. And for the second, you can see the coin only visible after the bowl filled with water, right? And for the third example there, if you look at the direction of arrow before the glass is filled with water, the arrow is pointed to the right. But later after you fill up the glass with water, then it changed direction, pointed to the left. So nothing to do with magic show. So all this example of phenomenon is due to refraction of light. All right. Okay. Can you hear me clearly? If you do, please give me number 1 in the live chat. All right. Okay, student, to talk about refraction, let us begin with characteristic of light. Okay. First, we understand that light can pass through transparent objects such as glass and air. Okay, thank you for your response, Nicholas and JTZY, whatever your name is. Thank you for being here. Okay, second, light travel in a straight line. Okay, when it passes through one transparent medium to another, as you can see in this diagram, there is a light ray traveling from air and then entering glass ray. Even though it changed direction, but still continue traveling in a straight line. All right. Okay, so the next slide tells us how does light travel in a medium. Okay, student, as you can see in this diagram, we have two medium there. The first medium is air and our second medium is glass block. Okay, so what we understand here, light ray bend when traveling from air into glass block. The word bend here refers to changing in direction. Okay, you can see it changed in direction from air into glass and then went back to air again. The direction is changes. Okay, so what causes the changes in direction, student? Actually, when light travel from air into the glass block, as in this diagram, its speed is reduced by the glass particles. Okay, so this is cause the change in direction. So the changing in speed causes the changing in direction when light travel from one medium to another medium of different optical density, we say. So from here, we can write the definition of refraction. Okay, in your textbook, refraction is a phenomenon, okay, where direction of light changes when propagating through two medium of different optical density due to the changes in speed of light. So there are three keywords there. First, changing in direction. The first keyword is changing in direction. Okay, second keyword, the light ray propagate through two mediums of different optical densities. And the third keyword, due to change in speed of light. All right. Okay, so this is all the terms you must know very well when discussing about this topic. I believe you're familiar with them since we meet with them in chapter 5 readily. Okay, the normal, a line perpendicular to the boundary of the two mediums. So this is the normal. Okay, an angle, a line which is 90 degree or perpendicular to the boundary between the first medium and the second medium. And then the incident ray, the ray in the first medium, angle of incidence is the angle between the incident ray and the normal. And then we have refracted ray, the ray in the second medium. Okay, an angle of refraction is an angle between the refracted ray and the normal. So I think this is the new terms for you, the angle of deviation with the symbol of sigma. Okay, so what is angle of deviation, student? If you look at this diagram, angle of deviation refers to the angle between the refracted ray and the original path of the light in the first medium. So if you look at the incident ray, this is the original path of the light ray. Okay, so this is the refracted angle, the refracted ray in the second medium. So the difference between original path and the refracted ray is called as the sigma. If I can magnify them for you, I think you can see more clear. Okay, this is our angle of deviation, the difference between the original path of the light in the first medium and the refracted ray. All right, okay. And if you look here, the higher the angle of deviation, it means this, the smaller the angle of refraction, where it means the light bend more towards normal. All right. Okay, so the next term to understand is optical density. Just now I mentioned refraction of light only occur when the light travel between two medium of different optical density. So what is the difference between density and optical density, students? So density defined as mass per unit volume. Okay, mass per unit volume, and it has a formula, rho equal m divide V, all right, with the unit of kilogram per meter cube, kilogram per cubic meter, all right. And if you compare two different liquid here, we have oil and water. Oil has a less density compared to water, that's why it float on the surface of water. Okay, density of water is greater compared to the density of oil if you talk about density. But what is optical density, students? Optical density is a measurement, okay, of the ability of an optical material or a transparent material to absorb or to bend light which travel through them. Okay, so if you compare again between oil and water, optical density for water is less compared to optical density of oil, which means the ability of light to show effect of refraction is less compared to oil. As you can see in this diagram, the thermometer appear to be bent more in oil compared to in water. Okay, the thermometer shows more refraction effect in oil compared to in water. So that's why the optical density of oil is greater compared to water. So are you clear the difference between density and optical density? If you do, please give me number 2. Why I want you to clear with this? Because when we talk about refraction, we always refer to the optical density of the medium. Yeah, good evening, Chia Yao. Long time no see. Thank you for your support. Okay. Thank you for your response, Tol and JTZY Nicholas as well. All right. Okay, so remember density and not necessary to be different. Okay, density is different with optical density. Lens is so hard though, is it? Which part? Or lens? Lens will talk later. Now we are talking about refraction of light. Lens you will find in 6.3 later, another 2 weeks. Yeah, so stay with me so to get more clearer understanding on lenses. All right. Okay, let us move to the next slide, student. Okay, now let us take a look. What is the relation between optical density of a medium and the speed of light on that medium? All right. Okay, so if you look in this diagram, student, when light ray travel through medium of different optical density, so the changes in light speed will causes the changes in direction. Okay, which means the light will be refracted. Okay, a medium that can reduce the speed of light, it's said to have a higher optical density. So from this statement, we understand the higher the optical density of the material, the lower the speed of light propagating through it. So as the result, the more the light bend from the original path. Okay. So I hope you're clear with this statement. The higher the optical density of the material, the lower the light speed propagating through it, and the more the light bend from the it will bend towards normal. So as you can see, we have two medium here, A and glass block. So from this drawing, we understand glass block has a higher optical density compared to A. So that's why it refracts the light towards normal, which means the speed of light decreases as it travels through from A through glass block. Okay, next. Okay, now let us take a look at this diagram, figure A. You can find this on your textbook as well. So in this diagram, refraction of light from A to glass block, where I is greater than R. Why I greater than R? Yes, because the light ray refract towards normal. So I will be greater than R. So based on this figure, what do we understand? Light ray bends towards normal when travel from a medium of low optical density, in this case air, to medium of high optical density, which is glass block. Okay. Second, why? This is because speed of light decreases as it travel from low optical density media to a high optical density medium. Okay, so due to this, angle of refraction will be smaller than the angle of incidence as it refracts towards normal. Okay. And in the second case, now refraction of light from glass block to A, the opposite. Okay, now you will find I less than R. Angle of incidence will be less than the angle of refraction. Why? Because now the light will be refract away from normal. So this is our reference figure, figure B. So the incident ray from the glass refracted here to the A. Okay, so light ray bend away from normal when travel from a medium of high optical density, in this diagram is glass block, to a medium of low optical density, which is air. Okay, so why? This is because the speed of light increases as it travel from low optical density medium to a high optical density medium. Okay, and students, due to this, R will be greater than I. Simple. Okay, so I hope you're clear with these two situations involving figure A and figure B. What happened when light refract from A to glass and from glass to A. Okay, so we've done with the first learning standard. Okay, now let us take a look at the second. To explain refractive index. Okay, what is refractive index? It is given with the symbol N. All right. Okay, so student, refractive index is the ratio. Okay, actually you can write refractive index in three ways. So this is the first way to write refractive index. It is the ratio of the speed of light in vacuum to the speed of light in medium. Vacuum here also including air. Okay, so ratio or speed of light in vacuum or in air to a speed of light in medium. So the formula is N equal C divide V. C is the speed of light in vacuum, 3 times 10 to the power of 8 meter per second, and V is the speed of light in medium, depend on what medium we have. Okay. So this is example, a few example of refractive index. So we have 3 diagram there. The first medium is all the same, which is water, but the second medium is different. For the first diagram, the second medium is perspex. And for the second diagram, the second medium is glass, flint. And for the third diagram, the second medium is diamond. And student, what is the similarity between these 3 diagrams? Can you tell me? Can you state one similarity between these 3 diagrams? Okay. Yeah, very good. All the angle of incidence is the same. Okay, the light is incident at angle of 50 degree. This one also 50 degree, 50 degree. Okay, And another similarity, the first medium is all water with a refractive index of 1.33 as shown in diagram there. Okay. Then when we talk about the differences, okay, what is the difference? Okay, the difference is the second medium. The first diagram has perspex with a refractive index of 1.5. Second diagram is glass with a refractive index of 1.66. And the third diagram is diamond with a refractive index of 2.42. And you can see as the second medium is different, so the light ray refracted at a different angle. 42.8 for perspex, okay, 37.9 for glass, and 24.9 degree in diamond. So what can you say about the angle of refraction? Okay, you can see when the refractive index increases, the angle of refraction decreases. Okay, this is what we can analyze from this diagram. Okay, and this table, student, shows to you a few example of refractive index for certain medium. Okay, we have vacuum with the lowest 1.0. Okay, water 1.33, perspex here in our diagram 1.5, glass free 1.66, and diamond 2.42. And what we understand from this refractive index, when the refractive index is greater, the optical density of the medium also greater. Okay, medium which has a higher refractive index also has a higher optical density. Okay. Okay, second. Now let us take a look at the refractive index and bending ability of a medium. Okay, here we have two comparison. The first diagram, the light travel from A to water with a refractive index of 1.33. In a second diagram, light travel from A into diamond with a refractive index from 2.42. So here we understand diamond has a greater refractive index compared to water. And you can see the light ray bend more, refract more in diamond compared to that in water. Okay. So refractive index determine the degree to which light bend when traveling from vacuum or A to a medium. Okay, so you can see here it indicates the bending ability of the medium. So there's an angle there, theta 1. Theta 1 is the angle of deviation, okay, in water, and theta 2 is the angle of deviation in diamond. So you can see theta 2 is greater, showing the bending effect for diamond is greater compared to that in water. So the higher the refractive index, the greater the bending effect, because the speed of light is lower. Okay, yes. So it causes larger angle of deviation, means the light ray bends more towards normal. So causes smaller value of R. Angle of refraction in diamond, smaller compared to angle of refraction in water. Alright? Okay, yes. So are you okay with the second learning standard? We learn about refractive index and how it relate to the bending ability of medium. Alright? Okay, now student, let us take a look at the third learning standard, the conceptualized Snell's law. Okay, so there's one formula here on Snell's law. Later we will see where can we apply this law. Okay, so law of refraction, students. Okay, law of refraction. Okay, first you must understand a law of refraction state that all the incident ray, the refracted ray, and the normal, they meet at one point and in the same plane. So this is the incident ray, this is the refracted ray, this is the normal, all meet at this point. Okay, this is the first law that you must understand, okay, to understand refraction. Okay, so according to Snell's law, okay, N1 is the refractive index of the first medium. Sin theta 1. Theta 1 is the angle of incidence here. N2 is the refractive index of the second medium, and theta 2 is the refractive angle of refraction. All right. So how do we relate this? According to Snell's law, it say the ratio of N2 to N1 equal to the ratio of sine theta 1 to sine theta 2. Okay, so student, when the first medium is A, okay, then the refractive index N1 is 1. Remember just now from the table, A has a refractive index of 1.00. Okay, so down here is 1. Okay, then where I is the angle of incidence in A and theta 2 is the angle of refraction in the second medium. So from here we can write N equal sine I to sine R. This is the formula for Snell's law, okay, where the ratio of sine I to sine R is a constant. Okay, so this is the formula for Snell's law. And this is the second way you can write refractive index. Refractive index is a ratio of sine I to sine R. Okay, the second way. The first way, refractive index is the ratio of speed of light in air or vacuum to the speed of light in medium. So this is the second way we can state refractive index, where it is a ratio of sine I to sine R. Alright, okay. So that's all with third learning standard to formalize Snell's law, where N equal sine I to sine R. But there is one terms you must obey when using this formula. When you are using N equal to sine I over sine R, I must be always in a less optical density medium and R must be always in an high optical density medium. Later we will look an example of question using that equation. Okay, student, our next learning standard, the fourth one, this is one experiment to show to us how to determine refractive index of a glass block or a perspex. Okay, maybe some of you have conducted this experiment with your teacher in your school. As for me, I am not done yet with my students. We will conduct all the experiment later after the exam because we have the exam earlier. It will started on October 1st for Form 4 in SMK Baganjaya. Can you share with me when you will be seated for the exam, Form 4 students? Okay, so this is our aim, to study the relationship between I and R, and second, to determine refractive index of a glass block. So the procedure you can read from number 1 until number 6. So finally, we will plot two graphs. First, graph of I against graph of R against I. Second, graph of sine I against sine R. And actually, this experiment have come out in UAS in a past year, but I don't remember the exact year. If I'm not mistaken, it come out on year 2022 or 2023. Okay. So this is all the variable related to this experiment: MV, angle of incidence, okay, our manipulated variable. So we conduct the experiment with a different value of I, and later you will see we will gain a different angle of refraction. Okay, and our CV constant variable is the refractive index of glass block, which means we use the same type of glass block. Okay. So this is the example of result you may gain from this experiment. So we increase the angle of incidence from 15 up to 80 degree. And this will be the angle of refraction measured from this experiment, starting from 10 until 41. And you press your calculator, this will be the value for sine I, sine R, and this is the ratio of sine I to sine R. Okay, if you look, the ratio is quite constant, 1.49, 1.54, 1.51, and so on. And then we plot a graph, or the first graph of R against I. So you'll find it is a straight line from the beginning, but it is a curvy towards the end. Okay. So from this graph, can we say R directly proportional to I? Yeah, cannot. Why? because towards the end it is a curved line. Okay, it is not a continuous straight line from the origin. So we can't say R directly proportional to I. We just say R increases with I. Okay, R increases with I. Okay. Then students, this is the second graph. We plot graph of sine I against sine R. Okay, now you'll find it is a straight line graph from the origin. So can we say sine I directly proportional to sine R? For this one, yes, we can. Okay, because it is a straight line graph from the origin. Okay, I feel bad for the students. Why you feel so tall? Okay. So what analysis we can make from these two graphs, students? So number one, we understand the angle of refraction in an optical denser medium will be less than angle of incidence. Okay. Second, when angle of incidence increases, the angle of refraction also increases. Okay. And third, we can say graph of sine I against sine R is a straight line graph through the origin. So this that shows sine I directly proportional to sine R. Okay. And number four, the gradient of the graph of sine I against sine R is a constant. So if you find a gradient along this line, the gradient is 1.5. Okay. So from the result, the gradient, okay, is actually shows to us what actually the gradient shows to you the refractive index of the glass block, which is 1.5. Remember from Snell's law formula, n equal sine I to sine R. So n is actually the gradient, okay, of sine I to sine R. So if you want to find the refractive index for the glass block, mean you have to find the gradient of the graph of sine I against sine R. So in this case, it is 1.5. Okay. Okay, so let us take a short break for a while. After we came back, we will see learning standard 6, the 5th, 2nd, and 7th learning standard, and we will see a few example of question related to refraction of light. So don't go away, student. I will be back after this short break. Okay, welcome again to our lesson. I'm Cikgu Hasnitah from SMK Bagan Jaya, Batawas Pulau Pinang, and you are now with me in free online tuition brought to you by Akademi Youtuber Malaysia, Kelab Guru Malaysia, and e-Didik Malaysia. Bermula percuma, selamanya percuma. Okay, student, before I continue, for those who are just being here, I have prepared for you a link, so you can click on this link to get your PDF copy for the slide I've been used in this lesson. It is actually the same one. Okay, only for your student copy, there is a few blank spaces you need to fill up, okay, in the exercise part at the back on this module. Okay, it's all for free. So jangan lupa boleh muat turunlah, cetak keluar dan gunakan bersama-sama dengan video ini. Okay, so now let us continue with our 5th learning standard, to explain real depth and apparent depth. So this is another situation where we can explain refractive index, students. So from the earlier learning standard, refractive index can be expressed as N equal to C over V. Refractive index is a ratio of speed of light in vacuum to speed of light in medium. And second, we can express a refractive index as N equals sine I divide sine R. If you write in words, refractive index is ratio of sine I to sine R. And the third expression is relating real depth and apparent depth. So as you can see in this diagram, the coin appear to be closer to the surface than the actual position is. And for the second diagram, similar. The coin which is placed on a swimming pool appear to be closer to the surface than the actual position. So what causes this situation? This is because light ray from the real coin travel from the water to the surface. So if you asked to draw a ray diagram from the actual coin. So we draw two light ray coming from the coming from the water towards the A. So when the light travel from water, which has a high optical density medium, to A, which has a low optical density medium, so we understand the light ray will refract, yes, away from normal. Okay, so it refract away from normal. This one also refract away from normal and enter the eyes of the observer. So when you extend this line, so this is where the position of the image of the coin appear at. Okay, and students, okay, so you will see the position of the coin just above the actual coin. All right, so we mark a few label there as the real depth. So the real depth is the actual depth of the coin from the surface. Okay, it is marked with capital H. And the apparent depth is the depth of the image of the coin from the surface. Remember, we measure depth from the surface to the object. Okay, not from the bottom. Okay, we measure depth from the surface to where the object at, or to where the image at. So apparent depth is given symbol small h. In some books, they are using capital D for actual depth and small d for apparent depth. Okay, but in our textbook, we are using letter H. Okay, so this is the formula, relate the refractive index and the real depth and apparent depth. Refractive index is the ratio of the real depth to the apparent depth. Okay, so N equal to real depth divide apparent, N equal to capital H divide H. So remember, this is the three ways you can state refractive index. Okay, later we will see example of exercises how to apply this formula. Okay, now this is another experiment to determine refractive index using real depth and apparent depth. You can also conduct this experiment in school with your teacher by using this material and apparatus as shown in this diagram. So our variable, our MV is the real depth. Okay, and our responding variable will be the apparent depth. So our real depth here is represented by pin O at the base of the beaker here, and our apparent depth will be determined by pin I. All right. Okay. So procedure you can read later from number 1 to number 8. We plot a graph of real depth against apparent depth. Okay, so student, this is the example of result obtained from this experiment. So the real depth is increased from 20 to 60. How we increase the real depth? By increasing the volume of water in the beaker. So when the volume of water increases, the real depth of the coin at the base will be increases. So from 20 to 60 centimeter here, and the apparent depth also will be, you will see the apparent depth will be increases as the real depth increases. Then we plot a graph of H against H. And again, you will see it is a straight line graph from the origin, showing that real depth is directly proportional to the apparent depth. Okay, and can you tell me what quantity represent by the gradient of this graph, student? Okay, can you tell me what quantity represent by the gradient of this graph? If we calculate the gradient of this graph, where the gradient is capital H, real depth divide apparent depth. So what quantity it will represent? Yeah, very good. It represents the refractive index of the medium, which is the water. All right. Yeah, very good. Okay, so this is the analysis and discussion we can make from this graph. First, apparent depth always less than real depth. Okay, then when the real depth increases, H also increases. Next, we can see graph H again says it's a straight line passing through the origin. Therefore, apparent depth directly proportional to the real depth, and the gradient, so this is the gradient, shows the refractive index of the water. So if you calculate the gradient here according to the data, the refractive index is 1.55, but theoretically it is 1.33. Okay. So conclusion, ratio of real depth to apparent depth give you the refractive index of the water, where N equal capital H divide small h. Okay. Okay, now we finish with the learning standard. Now let us test your understanding by solving a few example of problem or exercises relate to our topic today, refraction of light. Okay, so are you doing good so far with learning standard 1 to learning standard 6? If you do, can you give me number 3 in the live chat? Or if you have any question, you may ask in the live chat as well. Okay. Okay, let us take a look at the first question, student. It will be an objective question. Okay, please let's do it together. Okay, thank you Tol for your response. Okay, this is the first question. We have diagram 18 there. It shows a beam of light traveling from medium X into air. So this is medium X, the light incident at this angle. So can you tell me which one is the angle of incidence? 40 or 50? Student, which one is the angle of incidence? 40 or 50 degree? Okay, so you have to look it carefully. It is 40 degree, the angle of incidence. And which one is our angle of refraction in air? Is it 70 or 20? Definitely 70 degree. Okay, so find refractive index of medium X. Yes, good. Okay, which one is the answer? Angle of incidence in medium X is 40 degree and angle of refraction in air is 70 degree. So from this diagram, we understand when the light pass through from medium X to air, it refract away from normal. Okay, refract away from normal. Okay, and the angle of refraction is greater. So how to find refractive index of medium X? Okay, find it. Is it A 0.68 or B 0.82 or C 1.23 or is it D 1.46? Okay, for this question, you can straight away cancel A and B. You can straight away reject A and B. Why, student? Because refractive index of any medium cannot be less than 1, cannot be less than refractive index of vacuum or A. Okay, so A and B can be straight away rejected. So you consider, is it C or D? So which refractive index formula to be applied here? Remember just now we have 3 formula to find refractive index. The first one, N equals C divide V. So here does not involve speed, right? So we cannot use that. Second formula, N equals sin I divide sin R. Okay, and the third formula, N equal real depth divide apparent depth. So here we can use the second formula, N equals sin I divide sin R. And remember to apply this formula, okay, you must obey this condition. To apply this formula, sin I must be in A, okay, or in a low optical density medium, and R must be in the second medium, high optical density medium. So in this case, what we do, student, we apply the principle of reversibility of light. Okay, you have to change the direction of the light as it comes from the A into medium X. So we make 70 as our angle of incidence and 40 as our angle of refraction. So this is the condition you must obey to apply this formula. I must always in less optical density medium. So here we apply principle of reversibility of light. Okay. So answer is donkey 1.46. Alright. Okay, now second question. We have diagram 17. It shows a boy observing a fish in a pond. The fish appear to be closer to the surface of the water. So here involve real depth and apparent depth. Okay, so can you choose the correct reason to explain this situation? Is it A, refractive index of A greater than refractive index of water? Is it true? Or B, speed of light in A greater than speed of light in water? C, density of A greater than density of water. Okay, D, the frequency of light in A greater than frequency of light in water. So which one is correct? Which one is correct? Okay. JTZY, are you sure? C, confirm? You don't want to change your answer? Okay. Refractive index, we consider optical density, not the density of the medium. Okay, so Tol say B, but question mark here. Why not confident? Tol, what about the rest? What do you say? Okay, now GTZ will change to it. So answer is B, yes. Speed of light in A greater than speed of light in water. Student, we understand water has a high optical density compared to A. So when light travel from A to water, the speed of light will be decreases. Okay, the speed of light will be decreases. So it refracts towards normal. So the correct answer is boy. Speed of light in A greater than that in water. Yeah, very good. Okay, next question. Okay, another objective question. Now again, involve real depth and apparent depth. This is our actual object and the image is appear to be on top of that object. This is the eye of the observer. Okay, diagram 19 shows a coin in its image form in a beaker filled with water. Refractive index of water is given 1.33. So you can highlight this information. Okay, which combination is correct? Now you have to choose. If you understand the example of exercise we discussed earlier, you can answer this easily. Okay, Chia Ying, question 2B. Chia Yao, yes, very good. Okay. Okay, now the third question. What is the answer? A, B, C, or D? Real depth, 6.8. Apparent depth, 5.0. And then B, 7.6, 5.4, 8.8, 6.6, 9.2, 7.1. So how to do this? Actually, you can try. You must try all. Which ratio give you 1.33? Okay, which ratio give you 1.33 or closest to 1.33? So what is the formula apply here? We apply N equal real depth divide apparent depth. Okay, so this is the answer for A, 1.36. Answer for B, 1.41. Answer for C, 1.33. Answer for D, 1.30. So if you refer to the question, they give us refractive index of water is 1.33. So which ratio fits this? Answer is, how do you get 1.8? JTZY. The formula is real depth divide apparent depth. A, 1.36. Okay, B, 1.41. C is exact, 1.33. 8.8 divide 6.6. Okay, 1.33. And D, 1.3. Also, the exact answer is C. Okay, you can check back. All right. Okay. So for question 3, answer C. Okay, clear, students? Yeah, very good. Thank you. Thank you for your effort. Okay, now we move to question 4. Now we have a ray box here producing light incident at this angle. So this is, our first medium is air, our second medium is glass block. And the dashed line is the normal, a line 90 degree to the boundary of air and glass block. Okay, so it say the glass has a refractive index of 1.5. So you can highlight this information. All right. Okay, so the question is, what is the angle of refraction of the light ray? Student, find R. Find R. Okay, so which formula to apply here? We have N, 1.5. Okay, we have R, unknown. We need to find. Before that, can you tell me what is I? What is the value for I? Is it 30? Is 30 degree the angle of incidence? If not, what is our angle of incidence? Remember where to look at our angle of incidence. Angle of incidence is an angle between the incident ray and the normal. So this is our angle of incidence, which is 60 degree. Okay, our angle of incidence, 60 degree. So you have N, you have I is in air. So we have to find our answer 40, told 6. Okay. Okay, which one? Is it 19, 25, 35, or 49? So from this arrangement, we understand when light ray travels from A with the angle of incidence 60 degree, so it will refract towards normal with an angle of R. So R must be greater than 60. Here answer answer must be less than 60. So all the answer here are less than 60. So you have to calculate using formula for refractive index. So this is the formula we apply. N equal sin I divide sin R. So sin I is sin 60 degree. So sin R. Okay. N is 1.5. So can you solve from this? Okay. Can you solve from here? What is R? JTZY say 25. So answer is actually, how do you get 25? GTZY. Okay, can you check back? Okay, so from here, R is 35.2644 degrees. So the closest is C, 35 degree. Okay, the closest is C. Okay. Yeah, are you clear, student, how to get the answer for question 4? If you do, give me number 4. Okay. Or if you have any question, you may ask in the live chat as well. Oh, I forgot sign. Okay. Okay, so don't forget sign. Okay, N equal to sin I divide sin R. Okay. Okay, next question, student. Question 5. Okay, which statement is correct? Yeah. Okay, which statement is correct? Which statement is correct? When a light ray directed into a glass block as shown in this diagram, which statement is correct? So our first medium is light and this is our second medium, the glass block. So now we understand the light is travel from a low optical density medium to a high optical density medium. So what happened? Number 1, we understand the speed of light will be decreased. Second, the light will be refract towards normal. Alright. Okay, so which one? Correct or not? Light refract towards normal as it enter the glass block. Yes, appear to be correct. But we check all answer first. Okay. Incident angle is equal to the refracted angle. There is no way incident angle equal to be refracted angle. That is only happen in reflection of light. Okay. So this one wrong. Okay. Light travel faster as it enter the glass block. Actually, it travels slower. The speed decreases. So this is wrong. So for the brightness of light increases at travel in nothing to do with the brightness. Okay, this one is not related. So the correct answer is A. Yes, very good. For number 5, answer will be A. Okay. Next, number 6. Okay, now we have diagram 18. Show light ray moving from air into glass block. Okay, from air into glass block. So this is the incident ray. This is the refracted ray inside the glass block. So we have 4 angles there. W, X, Y, and Z. Can you tell me which one is the angle of incidence? Which one is our angle of refraction? Okay. I zoom it for you. Okay, which one is angle of incidence? Which one is angle of refraction, students? So this is our angle of incidence. Okay, this is our angle of refraction. So this one is easy. Angle of incidence is X, angle of refraction is Z. Yes, very good. Answer donkey. Yeah. Okay, next. Now let us move to a structure question. This is Terengganu Trial 2023. Maybe some of you have tried this question. Okay, first, diagram 2.1 shows a student observing a pencil inside a cup. The pencil appears to be bent due to phenomenon of refraction of light. Okay, first, what is meant by refraction of light? Remember the keyword? Refraction of light is the bending of light when propagating through two medium of different optical density, or you can say the change in direction of light when travel through two medium of different optical density due to the change in speed. Alright, okay, you can follow the definition I give you earlier in this lesson. Okay, next, explain how the phenomenon occur. Explain how refraction of light. Okay. JTZY say bending of light when pass from one medium to another medium. You add some more of different optical density. JTZY, then it will be complete. Okay. Bending of light when pass from one medium to another of different optical density. Please add of different optical density. Alright. Okay. So how refraction occurs, student? We explain how we explain. So you can write any of these point, any two of these 4 points. First, we can say light ray propagate from high optical density medium, which is the water, to a low optical density medium, to the air. Okay, or vice versa. Then speed of light in air greater than speed of light in water, or vice versa. Then the third point, you can say light ray refract away from normal. Okay, if you say travel from air to water, then it will be refract towards normal. It depends on your first point here. Okay, the third point depend on your first point. And then the fourth point, you can say angle of refraction greater than angle of incidence. This one also depend on your first point. If you say the light propagate from air to water, then angle of refraction will be smaller than angle of incidence. Okay, so the second, third, and fourth point depend on your first point. All right. Okay, and now for question C, diagram 2.2. You have to complete the ray diagram to show the position of image observed by the fish. So we have a fish down here inside the water, and there is a beetle. This is the actual beetle. The black color is the actual beetle, the real beetle, and the image is above, okay, on top. So how to draw? Okay, so this is how we can draw the ray diagram. Okay, so the light is coming from the actual beetle. So entering water, it will refract towards normal. Okay, and you expand this line from the refracted ray to the image appear to the fish eye. All right. Okay. So this is the ray diagram we draw for question C. Okay. Next, okay, now Selangor Trial Set 1 2023. We are given these two diagram 5.1 and 5.2. A ray is coming from the object in a glass entering A. Second diagram, the object is in a diamond, okay, entering A. And they give us angle theta1 here, angle of refraction for diagram 5.1, and theta2 is the angle of refraction in diamond in diagram 5.2. Another information they give us the refractive index for glass 1.52 and for diamond refractive index is given 2.42. So the object is at the base of the glass and diamond, and this is the position of image in glass and diamond respectively. Okay, so first, what is meant by refractive index, student? Okay, what is meant by refractive index? Remember just now there are three ways you can write refractive index. Okay, refractive index is a ratio of speed of light in vacuum to speed of light in medium. Second, you can say refractive index is a ratio of sin I to sin R. And third, refractive index is a ratio of real depth to apparent depth. So which of these three is related to this question? So we took the third definition. It is a ratio of speed of light. Okay, in this question they give us this answer, the first, but actually I prefer the third one. Ratio of real depth to apparent depth. How fast light travel in medium? It depends on what medium, JTZY. Okay, different medium has a different speed. Okay. So this one you can write the ratio of speed of light in vacuum to the speed of light in medium. Also you can write the ratio of real depth to apparent depth. Also you can write the ratio of sin I to sin R. So any answer is acceptable, any one of these three definition. Okay. And second, how do light bend when traveling from glass to air in diamond 5.1? So they ask you to explain why do light ray bend when traveling from glass to air in diagram 5. So how do we explain? So we understand refraction occur due to the changing in speed. So we can say the speed of light increases when traveling from glass, which is high optical density medium, to a low optical density medium, which is air. So it refracts away from normal. Okay. Okay, next. Okay, now we have to compare. Okay, compare in diagram 5.1 and 5.2. First, compare the refractive index. So you can see obviously 1.52 for glass, 4.2 for diamond. So which one is greater? Which one is lower? So we say refractive index for glass is less than refractive index of diamond. Or you can say vice versa. Refractive index of diamond is greater than that of glass. Second, compare the apparent depth of the image, students. So where to see the apparent depth? So this is the apparent depth for image in 5.1 and this is the apparent depth for image in 5.2. Okay, so you can say apparent depth of image in diagram 5.1 is greater. Okay, this one greater compared to that in 5.2. This one also you can write refractive index in diagram 5.1 less than that in diagram 5.2. Okay. Now compare the refracted angle theta. Compare theta 1 and theta 2. Which one greater? So if you look at this diagram, so diamond has a greater refractive index. So we understand the light will be refract more in air. So the angle of refraction will be greater in diamond. So we say the refracted angle in diagram 5.1 less than that in diagram 4.0 or vice versa. You can say the refracted angle in diagram 5.2 is greater than that in 5.1. Okay. So are you doing good with this question, students? Can we move to the next? Okay, I hope you do. Okay, now based on our answer in B, now we have to write a relationship. Okay, this pattern of question you will find in question 5 and question 6 in paper 2, section A. All right. So how do we relate refractive index with apparent depth? Okay, so from this diagram, we can see refractive index increases. Okay, the apparent depth decrease. Okay, when the refractive index increases, apparent depth decreases, or vice versa. Yeah, Mr. Madan Mohan give us the speed of light in millimeter. Thank you very much for your info. I really appreciate it. Okay. Given there 225,000 kilometer per second in water, 200,000 kilometer per second in glass, 125,000 kilometer per second in diamond. Thank you very much for your sharing. I really appreciate that. So I hope it answered a bit my question, JTZY. All right. Okay, now compare the refractive index with the refracted angle, students. Okay. Compare the refractive index and refracted angle. So we say the higher the refractive index, the higher the refracted angle. Or you can say when the refractive index increase, so the refracted angle increase. Okay. Can we say directly proportional here? I recommend you to write increase, 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 decrease, because there is no graph or no formula relating them. So just write increase, increase or increase, decrease based on our observation. All right. Okay. Now, the diamond block in diagram 5.2 has a height of 4 cm. Okay. This is the information we are given. The diamond in block 4.2 has a height of 4 cm. So what is this information tells us? 4 cm is actually what? Find the apparent depth of the image. So actually 4 cm is the, yes, is the actual depth. So our actual depth here is 4 cm. And the diamond has a height of 4 cm. So this height actually our real depth, which is h. So we have to find this apparent depth, which is small h. Okay, and the refractive index is 2.42. So from here, what is the apparent depth? It is 1.6529 centimeter. Okay. Okay, good. Okay, now let us move to the next question. I think this is the last question for this evening. Percubaan Negeri Kelantan 2023. Okay, we are given diagram 11.1 and 11.2. It shows a light ray from A moving into material X in 11.1, and we have material Y in 11.2. So the light enter at the same angle of incidence of 40 degree. Okay, in both diagram, but later we'll see the angle of refraction is different, 25 degree in X and 15 degree in Y. So it refract more in material Y. So we understand material Y has a higher optical density compared to material X. Okay, the ability to bend light is greater compared to that material X. And given the speed of light in material X, 1.97 times 10^8 and 1.2 times 10^8 in material Y. So the speed of light lower in material Y. And the refractive index of X is given 1.52 and 2.48 for Y. Okay, so these all are important information given. Okay, first, compare angle of incidence. Second, compare refracted angle. Compare speed of light in X. So you have made 3 comparison here. And then relate the speed to the refracted angle and relate refractive index with the optical density of the material. So how to write? Please write them one by one. Okay, you write them separate. First mark, we compare the angle of incidence. Okay, so angle of incidence in 11.1 equal to that in 11.2. Same. Okay, both 40 degree. Same. Okay, then compare the refractive angle of refraction. 25 here, 15 here. So when you compare, please don't write the value. That is not comparing. Okay, when you compare, either it is equal, one greater than another, or which one smaller than another. Okay, so for the refracted angle, in diagram 11.1 is greater than that in 11.2, or vice versa. Okay, you can say 11.2 less than that in 11.1. Okay, third mark, compare what? Compare the speed of light. Okay, look at the speed of light. Okay, speed of light in diagram 11.1 greater than that in 11.2. So 11.1 can be referred to X, 11.2 can be referred to Y. Alright? Okay, so 3 comparison, 3 marks. Okay, then relationship. First, relate refracted angle and speed of light. Okay, second, relate refractive index with the optical density. Okay, so how we relate speed and refracted angles? You can say speed of light increases, refracted angle increases. Okay, speed of light increases, refracted of light increases. Okay, so the fourth mark. And the last one, compare refractive index and optical density. Refractive index increases, optical density increases. Okay, so from this situation, we understand material Y has a higher optical density compared to material X. So it refracts light towards the normal more compared to that of material Y. Alright? Okay, and last question for C. You are given diagram 11.T. It is an incomplete ray diagram. So you have to complete them. Okay. Our light here is incident at this angle. Is it 30 degree angle of incident? Can you tell me what is our angle of incident here? It is not 30 degree, but this is our angle of incidence up there, 60 degrees, student. Our angle of incidence is this 60 degree. Sorry for the poor handwriting. Okay, 60 degree, our angle of incidence. Okay, so now it will travel through Y and then travel through X. Okay, so your task is to complete the ray diagram in material Y and material X. Okay, so just now from the previous question, okay, from the previous slide, our X has a refractive index of 1.52 and 2.48 for Y. So 1.52 for X. X is down here and 1.52. And Y is up here with a refractive index of 2.48. Is it correct? Let us check back. Yeah, okay, 2.48. So from A to Y and then to X. Okay, how to draw? So from A to Y, so what happened? It will be refract towards normal, right? This one low optical density, this one high optical density. So it will refract towards normal. And then at this boundary between Y and X, so we have from higher optical density to less optical density. So it will be refract, yes, away from normal. Okay, so how to complete our ray diagram? Okay, so this is how we do it. Okay, sorry. Okay, we go back to the slide. Okay, I erase first the refractive index already. So this is the explanation. Okay, first, light ray entering material Y refract towards normal as optical density of Y higher or greater than A. Okay. Second, light ray entering material X refracted away from normal since optical density of X lower than that of material Y. So 4 marks. Okay. So the first mark, this one you draw correctly, refract towards normal, and then here second mark, you draw away from normal. So how to get the third mark? Third mark. Okay, third mark. Okay, don't forget to write the arrow, student. Okay, the arrow. Okay, arrow to show the direction of propagation of the light. So simple, right? Okay, so I hope you are clear with 6.1. I guess that's all the time we have for this evening. Now it's readily 9:25 p.m. So I really appreciate the time and effort you spent with me together in this class. Started from 8 past 15 until now. Okay, so I hope this lesson will help you to understand this topic in a better way. Okay, so this is the link for eCert. You can click on them, fill up with your name and IC number correctly, and it will send to you just in a glance in an email which you are using. You can use any email to fill up this eCert link, student. Okay, again, I would like to say thank you very much for your time and effort. Terima kasih banyak-banyak di atas masa dan usaha yang anda tunjukkan. Jangan lupa boleh download nota dan latihan yang cikgu kongsi tadi. Just click on this link and get your PDF copy for free. So you can come back to this video anytime you are free to get the full answers for the exercises we discussed just now. Okay, terima kasih banyak-banyak. InsyaAllah kita jumpa lagi minggu hadapan pada hari Jumaat bersama dengan Cikgu Rosemawati dalam slot School A+, SPM, Jumaat 9.30 malam dan hari Ahad 8.15 malam bersama dengan saya lagi Cikgu Hasnitah dengan tajuk yang seterusnya 6.2 Total Internal Refraction. Okay. Sekali lagi terima kasih, yang baik kepada Allah, yang kurang itu daripada kelemahan dan kedangkalan ilmu cikgu. Semoga anda semua sentiasa diberi kesihatan yang baik dan selamat maju jaya dalam apa jua yang anda usahakan. Assalamualaikum, jumpa lagi dan selamat malam semua. Bye-bye.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.